Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on the structure of the atom. In our last lesson, we discussed the classical theories of the structure of matter. We examined the theories of Democritus, Aristotle, and Dalton. With the help of your teacher, you will have learned about the modern atomic theory. Today, we will continue learning about the structure of the atom by introducing the characteristics of an electron. Let us begin. In our previous lesson, we discussed how some of the postulates of Dalton's theory have been disproven. Further investigation into atomic structure presented the possibility that subatomic particles existed. A series of breakthroughs in research concluded that atoms are made up of three different kinds of subatomic particles: the electron, the neutron, and the proton. The electron was the first subatomic particle to be identified. This long-term study began in 1879 when scientist William Cooke conducted an experiment in electrical discharges. A discharge tube is a sealed glass tube in which a gas is partially filled at low pressure. On either side of the tube, there are two electrodes sealed inside. The negative electrode is the cathode, while the positive one is the anode. When the current is turned on inside the tube, a ray of light can be seen at the anode, which originates from the cathode that travels in a straight line. These beams are called cathode rays. In a cathode ray, an object placed between the cathode and the opposite end of the tube will cast a shadow on the glass. This shows the cathode rays traveling in a straight line. When a paddle wheel is placed between the cathode and the anode on the path of the cathode rays, it rotates on its axis from the cathode to the anode. This proves that cathode rays consist of particles that have mass. In 1897, physicist J.J. Thomson used cathode rays to demonstrate a newly discovered phenomenon, that they were, in fact, affected by both electrical and magnetic fields. When an electrical or magnetic field is applied in the path of the cathode ray, it is deflected towards the positive plate. Thomson conducted this experiment with several different electrodes and gases, but the results were always the same. This allowed Thomson to conclude that cathode rays are made up of very small negatively charged particles, which he named electrons. It was Thomson's theory that electrons are constituents of all matter because, despite the difference in gas or charge in the cathode ray tube, the negative charge remained. Cathode rays provided evidence that atoms are divisible into smaller particles, and proof of the existence of the electron led to significant leaps forward in the study of atomic theory. Students, let us do an activity. We have discussed many philosophers and great thinkers that have introduced many ideas to the modern atomic theory. Can you match up the names of the scientists and philosophers on the left with the most appropriate statement of their beliefs on the right? You may begin.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. I hope you had fun with this activity. If you were able to match the names on the left to the statements on the right, as you see here, you are correct. Well done. Let us do another activity, students. What components make up a cathode ray tube? Please write down your answers now.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, everyone. Did you find this activity more difficult? Let us see if you were able to list all the components. We begin with a glass tube that has no air inside. At either end of the tube is placed an electrode, one cathode and one anode. These are negatively and positively charged, respectively. We also need a gas at low pressure to monitor the movement of a cathode ray. If these were your answers, once again, great job. I have one more exercise for you. As a group, please discuss why it is important to study these theories and experiments, even though they may be outdated today. Take a few minutes to do this now.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. I hope you had an interesting conversation as to why we study these theories and experiments. It is important to realize that even though these theories may be somewhat incorrect, the correct information we have gathered is based on some of these basic concepts. Even Democritus's theory of the atoms has been modernized today, though his theory was established more than 2,000 years ago. It is critical to study the breakthroughs in research that have been made, because It will provide us with understanding as to the kinds of thinking that were required to reach these conclusions. Maybe one day you will look back on this data and make an incredible discovery because of it. This brings us to the end of today's lesson. We have discussed the discovery of the electron by J.J. Thomson and the experiment that proved its existence using the cathode ray tube. Our next lesson will focus on the second constituent of the atom, the nucleus. Until next time, thank you, teacher. Thank you, students.